So the two indicated regions of the graph that are in green are indicating where the velocity is positive, and that's indicating where the graph is moving to the right. So it moves right for 0 to about 1.153 and 3.180 to infinity. Alright, where the graph dips underneath the x-axis, it's going to be moving left for those values of t, and so it moves left for 1.153 to 3.180. And all of this is the answer to A. Alright, to answer question B, the particle is going to speed up when the velocity and the acceleration have the same sign, and then it slows down when they have different signs. Alright, so on a number line, we can represent where the velocity is positive and negative, just like we did on the graph. But now we need to figure out where is the acceleration positive and negative. So what behooved me to find the function for acceleration, which is 12t minus 26. And so that function is 0 when t is equal to 13/6, or about 2.167 seconds. Now if I graph that function on the same function as velocity, this point right here is going to be 2.167. So rather than try to cram it in on this graph here, I think I'm going to use my number line and show you that the acceleration is negative for all values up to that point and positive after. So now I can see exactly where my intervals are at. In the turquoise region here, they're mixed. And in this turquoise region, they're mixed. So I know that it slows down over those regions. But in the other two regions, they're the same color. Signs are the same, so they speed up. Okay, so in conclusion, the particle speeds over these two intervals and slows over these two intervals. Finally, the last question, we've already got all the info to answer it. There's a change of direction when the velocity changes signs. So it changes signs at